we don't need to implement Ethereum's immutable contract logic. We can allow a smart contract developer to choose to make their contract immutable.
Hi, I'm Andrew Levine, the CEO of Koinos Group, and in today's episode of the Koinos Group podcast, I'll be interviewing one of my co-founders here at Koinos Group, Michael Vandeberg. He's one of the blockchain architects working on Koinos, and we're going to talk about upgradable smart contracts. Upgradable smart contracts are really important for two reasons. One is they make the lives of smart contract developers, decentralized application developers, a lot easier. But the upgradability of our smart contracts is also critical to one of our core value propositions in the Koinos blockchain, which is its modular upgradability, the ability to add any behavior to the blockchain without a hard fork. This makes hard forks no longer necessary. Doesn't mean there will never be hard forks, but it means that we can add features to the blockchain without requiring a hard fork. And we think that that's a really fundamental shift. But in order to understand how all that works, you first have to understand how upgradable smart contracts work, which isn't something everybody's familiar with because a lot of people tend to assume that because blockchains are immutable, that you can't allow certain parts of the blockchain to change, like smart contracts. So in this conversation, I talked to Michael about that, and hopefully you'll gain a better understanding of all of this by the end of the discussion. Enjoy.
So I think the best place to start is just looking at how Ethereum does things, and then we'll immediately change our assumptions, and that will change the game for you, okay? And that is when you upload a smart contract to Ethereum, that contract gets an address. I believe it's probably based on like a hash of the bytecode or something similar, plus maybe something else so you could have the same contract uploaded multiple times, but with different addresses. But essentially, a unique address is generated when you upload a contract. And that contract is there forever. If there's a bug in it, it's there. And so on Ethereum, upgrading a contract requires forward thinking. Which is why you've got like proxy contracts. The contract code itself is permanent. It cannot change. And therefore, if I want to modify behavior, I need to be forward thinking and provide a mechanism within the contract that allows it to get behavior from a new contract that doesn't yet exist. So we've got all these proxy systems and things in place, and there are mechanisms, well-known design patterns in Ethereum that let you do that. However, those are all solutions to the problem of the smart contract is immutable. So the simple way to think about it is, well, what if a smart contract is not immutable? What if I can change it? Well, that just means I could upload a new smart contract to the same address that an existing smart contract lives at, and I would replace its code. So from from a technical perspective of upgradability, upgrading a smart contract is trivial. It brings its own set of problems. I create Uniswap on Koinos, right? And I create the Uniswap token, and I've got all these market makers that are controlling funds, et cetera, et cetera. And my credentials get hacked. Someone could upload a contract to overwrite my Uniswap contract, and now they've got access to the market makers and to the balances that that contract controls. So being able to just pop in a new contract does create a security vulnerability, but there are mitigations against that. The easiest mitigation is I upload a contract, and then I update the authority for that contract to be null, and I mathematically say, nobody can ever satisfy this authority. Therefore, the contract can never be a new contract can never be uploaded. So essentially, we don't need to implement Ethereum's immutable contract logic. We can allow a smart contract developer to choose to make their contract immutable. And by allowing them to choose to make their contract immutable, we also give them the choice of how they want to secure their contract. And so part of that can be, an example is the Koinos system calls can be updated and banned. Right now, those are just updated by matching one particular key, which is horribly insecure. Long term, the governance system is going to be tied in with that, so that only through an active governance can a system call be upgraded. So that's the essentially the authority that is required is an active government. Likewise, a smart contract developer could update the authority for uploading a new smart contract to be even defined by the governance of that smart contract. Like, you could create a governance model within your smart contract that then is required to pass in order to update itself. You could make an external authority. Heck, you might even decide that we want to maintain the ability to upgrade our smart contract whenever we want, because we're running a game, right? And we need to make upgrades to support new versions of the game. But in order to do security, maybe you create it as a 3 of 5 multi-sig, which is, going to be, it's not foolproof. It could still be updated maliciously, but you can increase the level of security required to a more than acceptable level. And so I'd say we just sort of subvert the assumption of Ethereum, right? That every single smart contract is immutable, and we provide that flexibility to the developer and say, what type of security do you need on your smart contract? If you need immutability, that is supported. If you need some other form of authority, either there'll be smart contracts out there that implement it, or you can write a smart contract to implement that authority for yourself. So the same sort of flexibility that we have in designing the system itself, like, applies to almost every aspect of the Koinos design, and in this case, how smart contracts are upgraded.
I guess people tend to assume that if something is on a blockchain, it can't be changed. And
I don't understand. Well, a record of it cannot be changed, but saying that it's on a blockchain, it can't be changed, is a weird assumption, because you use it for currency and your balances are changing. Like, okay, with Bitcoin, yes, that's
a very good way of putting it, I think. Yeah.
So yeah, with Bitcoin, yes, that is the case, because your balances are a sum of unspent transaction outputs, and those transaction outputs are immutable, right? If you want to spend a partial transaction output, you need to send it to one place and then have the two new outputs equal the sum of the inputs. So yes, Bitcoin is immutable in that perspective, but Ethereum's not at all. Like, your balances are recorded in a database, and those database records change. A smart contract is just a database record. That database record happens to hold executable code instead of data, but it's still a database record.
So Ethereum actually did additional work. There's an additional system in there to make smart contracts immutable. And basically what we did when building Koinos was more about leaving a system out rather than creating some additional system.
So I wouldn't necessarily say like Ethereum did extra work. They implemented a whole lot more natively. Like ETH is implemented natively. Their smart contract stuff, like, there's a whole lot of the stuff that's implemented natively. And by native, I mean in the example of Geth would be in Golang, right? You're implementing it in the implementation language, not in the VM language. And yes, our contract uploading is implemented in C++, but it's a system call that can be overloaded. So an aspect of it could be implemented in VM. Yeah, we could re-implement uploading of smart contracts entirely in the VM. So essentially it's because our system calls all need to be, we want them to be upgradable, and that upgrade happens in the VM. Like even if we have a native C++ implementation, like the stuff that it does still needs to be the same stuff that the VM can do. And so as a requirement of that flexibility, we can't treat contracts differently than other database objects.
It's still not clear to me why Ethereum contracts are immutable, what they did differently than what we're doing.
It's because the flexibility is not a design principle. It doesn't make sense for that. Like if our authority system was not also able to be defined within smart contracts, I would argue against mutable smart contracts simply from the security perspective.
I think that's the missing piece for me.
Yeah, because everything is in the smart contracts, like we can leave it open-ended and leave it up to the developers on how they want to secure their smart contract, and still support immutable smart contracts if that's the way they choose to go. And I imagine a large percentage of smart contract developers will choose to do that because that's already how smart contract development works. And it's sort of like, well, we could try something else out, but like you really don't probably want to be the first smart contract that like uses self-governance to update itself and then be the next DAO, right? And get it wrong.
Yeah.
Like there's a whole lot of reasons to want to do something like that, but you really don't want to be the first. And so I think to some extent that fear of what if we get it wrong will probably lead some developers to just do things the way they're currently doing it, even if they could do it more efficiently in a new way.